Okay, category 2, representational tools to solve problems. We're going to start with a quick review of exponent rules. So I have a lot of things going on. I've tried to pick ones where there's a lot of rules being used so we can review as much as possible. So right here, I have an exponent outside, and I have exponents inside. I have exponent outside and exponents inside. So order of operations says first simplify anything in the parentheses, which I can't do here. And the second thing is to take care of any exponents. So this is my very first step here. So this is going 4 to the third power, a to the third power 3 times, so a to the 9th power, c to the second power 3 times, so c to the 6th power. So there's my first term, and I'm multiplying that by -3 to the second power, a to the second power, and c to the 4th power twice, or c to the 8th power. Okay, so now I can simplify this into one term, so I'm going to multiply my coefficients. So I have 4 to the third power, which is 4 times 4 times 4, or 64, times -3 squared, which is going to be a positive 9. So I'm going to multiply those coefficients right there. I have 9 a's here and 2 more here, so I'm going to have a total of 11 a's. I have 6 c's and then 8 more c's, so I'm going to have a total of 14 c's. So then 64 times 9 gives me 576. So that's going to be my coefficient here, 576 a to the 11th, c to the 14th. And since I have two variables here, this is not a problem I can check by graphing. Okay, down here I have two binomials multiplied, so this is FOIL, first times first, which is going to give me 4x squared. Outer times outer, which is going to give me negative 10x. Inner times inner, which will give me a positive 10x. And then last times last, which is negative 25. And we're going to combine like terms, so I have 4x squared. And in this case, I had a negative 10 and a positive 10, so those are going to become 0x. So I don't need to write that down. Minus 25. And there's my simplified version. 3x plus 4 squared. Now please do not try to distribute this squared to each of these, because unlike the ones up here, where this was all multiplication inside, this was only one term, there are two terms here, which means you cannot distribute that too. So what this really is saying is 3x plus 4 times 3x plus 4. And then, just like the one above, we're going to FOIL out. So we're going to get 9x squared plus 12x plus 12x plus 16. Put our like terms together. So we're going to have 9x squared plus 24x plus 16. And that's our final answer there. Okay, let's look at when we have something other than multiplication here. So in this case, we're subtracting these two terms. two polynomials here. So we're going to begin with order of operations. We're going to distribute right here. So 2 times 5x squared is going to give us 10x squared. 2 times negative 3 is going to give us a negative 6xy. 2 times 2 is going to give us a positive 4y squared. Okay, so that 2 only goes to the parentheses that it's right next to. Now over here, I have actually a negative 1 out front here. So I'm going to distribute that all the way through. So negative 1 times 3x squared is a negative 3x squared. Negative 1 times a positive 2 is going to give me a negative 2xy. And then a negative 1 times a negative 1 here is going to give me a positive 1y squared. And then I'm looking for what can I put together here. So I'm going to put my x squared terms together. I had 10 here, and I have a negative 3 here, so 10 minus 3 gives me 7x squared. I have a negative 6xy and a negative 2xy here, so that's a total of negative 8xy's. And then I had 4y squared and another y squared, so I have a total of 5y squared terms. And that's going to be simplified there. Okay, we also have division with exponents, and this also includes, this one has a negative exponent. So that's the first thing we're going to deal with, is it has that negative exponent. We need to move that. So if it doesn't have a negative exponent, it's going to stay right where it's at. So this is going to stay on the top, and this is going to stay on the top. And negative numbers are fine, so that negative 25 is fine there. X squared, that was positive exponent. So to y squared, that was already there. But then I'm also going to bring down the y squared from on top. And remember, when I move it, it's now positive. Right, so now I have this. So I'm going to divide my coefficients. Negative 25 divided by 5 is going to give me a negative 5 in the numerator. I have 4 x's here, and again, you can expand this out and just mark through sets and see what's left. But I have 4 x's on the top, I have 2 x's on the bottom, which is going to leave me with 2 x's on the top. I have a z on the top and a z on the bottom. Those are going to become 1, so we're not going to write those down. And then on the bottom, I also have 2 y's and then 2 more y's, so a total of 4 y's. So my final answer is negative 5x squared over y to the 4th. And then I have this, and this whole thing is squared. It's inside these parentheses, which means everything in here has to be raised to the 2nd power, including my numbers. So I'm going to begin with 4 squared, which is 16. M to the 3rd squared, so I have m to the 3rd twice, or m to the 6th power. I have n squared, p to the 5th twice, or p to the 10th power, over 16 squared, which I believe is going to give me 256. M squared twice, so I've got m to the 4th power, n squared twice, so n to the 4th power, p squared twice, so p to the 4th power. Okay, let's see if we can then simplify this a bit. So 16 over 256 should reduce down to 1 over 16. I don't need to write my 1 up here. I had 6 m's on top and only 4 on the bottom, so I'm going to have 2 left, and they will be on the top. I had 2 n's on top and 4 on the bottom, so I'm going to wind up with 2 n's left, but they will be on the bottom, because there were more there to start with. I had 10 p's on the top, 4 on the bottom, so there were more on the top. I will have 6 left there. And that is my simplified answer. Again, can't graph those to check them. Okay, so how these appear in word problems. This one is really pretty simple. You have an isosceles triangle, sides represented by these expressions, and I want to know the perimeter of the triangle. So perimeter, of course, is adding the three sides together. And so since it's isosceles, whatever this side is the same over here. So this is also 3x squared plus 5x minus 4. And we're just going to add those up. So I'm going to go ahead and group my like terms as I go and put them under each other just to make adding a little easier. So 3x squared plus 5x minus 4 once. And I need that again for that second side. And then I need my base, which was 2x squared minus 8x plus 3. And I'm going to just combine all my terms. So I have negative 8 plus 3, or negative 5 here. I have 10x minus 8x, which leaves me with 2x here. I had 6, 7, 8x squared. And this was a positive 2. So this is the perimeter of the given triangle. Okay, question taken off of relates to EOC. The base of a triangle is 3 inches less than its height. Twice its height. So if the area of the triangle is 126 square inches, which of the following equations can be used to find h, the height of a triangle in inches? So let me draw a picture. So we're trying to find h. We don't know what h is, but we know it's called h. We know that the base is 3 inches less than twice the height. So about twice the height, and it's going to be 3 inches less than that. And I know formula, and this will be on your formula chart for a triangle, area of a triangle, is 1/2 the base times the height, or base times height divided by 2. They told me the area is 126 square inches. So I've got 1/2 times 2h minus 3 times the height. So you can see already that I've got an h term here that's going to be squared. So we're just simplifying from here then. So 126 is equal to 1/2 of, and so we'll distribute right here, 2h times h, 2h squared, negative 3 times h minus 3h. And then we're going to go ahead and multiply by 2 here to take care of that fraction. So when I multiply by 2 on this side, I should get 252 is equal to 2h squared minus 3h. And then I'm going to move this over here. So here we have 2h squared minus 3h minus 252. And that matches up with answer choice D. Okay, next, this is also supporting standard, is to use complex numbers to describe solutions of quadratic equations. So we're going to go through and just look at simplifying complex numbers. Some of us are still having a hard time with this. So these are all really simple ones because they are perfect squares. But just to remember that when you get a square root with a negative number on it, that is an imaginary or a complex number. So that needs to become I on the outside, and so that makes that positive. So now it's I on the outside. outside and you have a square root of a positive 36. And then we can simplify that further because the square root of 36 is 6, so that becomes 6i. Well, we always write the real part in front of the I, just like we normally would 6x there. So that would be written as a complex number. Same thing here, so this becomes plus or minus, and square root of 49 is 7, and since it was a negative, we have to have that I with it. This becomes 11i. This becomes 9i. 10i. Now this has a negative out front, so that's going to change my answer in the end. I'm going to have a negative for I, because once I take my square root of 16, now it's multiplied by negative 1 here. And this becomes 12i. So when you have a number out here, whatever you bring out is going to be multiplied by that number. So this becomes 11 times 9i. And just like with any other variable, if that was an x, then you would just multiply those and it becomes 99x. Well, the same thing happens here. It becomes 99i. So we can combine when it's multiplication. So this becomes 3 times 3i, which is 9i. This is going to be negative 2 times 4i, or negative 8i. But when it's not multiplication here, when you've got addition or subtraction, then it's a matter of are they like terms. And so if that was an x, then you would say no, they're not like terms, so we can't combine them. Well, the same is true here. So you're going to have 16 minus 4i, and that's all you can do there. Here you're going to have negative 24 plus or minus 3i. You got 16 minus 13i, 2.6 plus 9i. So they're just wanting you to see that they come in all different forms here. 3.5 plus 1.1i, negative 48 plus or minus 16i. And that's just simplifying. And of course the reason you need to know how to do that is because when you do faster, and so that's part of this is to solve. So I haven't gotten very far in our category. Okay. So when I have a quadratic like this and I'm solving, so we are doing, because that's going to be a fraction. This formula is on the formula chart. It's not something you can imagine. So negative 3 plus or minus the root of negative 3, make sure you put that in parentheses squared, minus 4 times 1 times 10, all divided by 2 times 1. So that's going to be positive 3 plus or minus the root of positive 9 minus 30, so it's going to be a negative 31. And I chose this one because 31 does not have a perfect square, so I wanted to show you that sometimes you just leave that. So this is going to be 3 plus or minus. Now I can't leave the negative, so I have to bring that out as an I. But if what you have under your radical is not a perfect square, then that's going to stay there, divided by 2. And so those would be your solutions there. And you can estimate or approximate that to a decimal, but chances are you'll see it coming back. Analyzing equations and formulating systems of equations into a law and then for inequality and solving. This is 11. So basically this is write your equations and then solve. So we'll go back to how to solve and we'll look at matrices in a second, but right now we're just writing and setting these up. Okay, so our example here is the school jazz ensemble. Collects 1,670 for 300 tickets sold for the concert. Adult tickets for 9 each, student tickets for $4 each, and then each were sold. So we're going to set up two equations here. And in systems, there's always at least two equations. So let's start with our sentence about dollars. And let's go ahead and sign our variables that A be adult and let's set S be student. So we're going to say dollars, adult, plus dollars for student equals dollars student. On the sentence, everything I wrote out is dollars. My second sentence is going to be about how many were sold. So this is how many. So I have some number of adult tickets plus some number of student tickets. Altogether were 300. I don't know exactly how many of each have the same common point. So then it's setting up the equations, and now we're solving. So in this particular situation, because this is a time test, I would say let's go ahead and bring the calculator up here. And just review. We kind of looked at this briefly a few weeks ago about how to get to LinSolve, and even in test mode, the calculator will still work. We'll still do this. And then we're also going to talk about how to do all the solving algebraically and graphically, because we could see questions related to that. So this should not be the only way you know to solve. Okay, so this works pretty much like NSolve. We're going to add a calculator page. And we will go menu 3, menu algebra. I don't want NSolve. Menu 3. Menu 3, and I want number 2. Solve system of linear equations. And so this is asking how many equations. Well, we have 2 equations. And then for ours, we're actually going to change this because we're using A and S, and we're going to put it in the exact order that we did this in. So our equation, first equation was 9A plus 4S, and so for this we put in exactly as it is, even if they're not in standard form. And we have to have equals, just like we did in NSolve, equals 1,670. And we have A plus S equals 300. And so the first answer is going to be whatever my A value is, because I put A first, and the second is going to be whatever my S value is. So that means that we sold 94 adult tickets, and we sold 206 student tickets. 94 adult, and what did we say? 206 student tickets. So that's going to be your fastest method for solving, but we also need to know the other methods. We're also going to look at inequalities here. So this is an inequality problem. The first of 2 numbers minus 4 times, and then a second number is at least -4. 3 times the first number plus the second number is more than -3. So we're going to use x is the first number, y is the second number. So the first of 2 numbers, so that's going to be x is okay, the first of 2 numbers, so x minus 4 times the second number, so 4 times y, is at least. So at least means it has to be 4, can't be less than 4, so it has to be greater than or equal to 4, so at least means greater than or equal to 3 times the first number, so 3 times x, plus the second number, is more than, or greater than, but not equal to, -3. So we set up our system of inequalities, and we're going to locate all possible solutions here. And we're doing this by graphing, which means we're going to put this in terms of y equals. I've got negative 4y is greater than or equal to, and then move that x over, so negative x minus 4. I'm going to divide by negative 4, which means I'm going to reverse my inequality. And so that's going to become a positive x over 4, and it's going to become positive 1. So then this one is going to be y is greater than negative 3x minus 3. Alright, so let's start with this one here. Y-intercept is at positive 1, so we'll put it there. The rise is 1 over 4, so I'm going to rise 1, run 4, rise 1, run 4, and so on. And go back this way. Alright, and so then this is a solid line because we have the equal bar with it, so when I draw this, it's really hard to draw straight on this tablet here. Something along here. Very bad here. Then this one is going to be y-intercepted negative 3, and I'm going to go down 3 over 1, so this line is decreasing. So, and then this does not have an equal bar with it, so when I draw this line, it will be a dotted line. Okay, so now I have to find my region. So for this line here, it was less than, so that means that I was shading in everything less than, or below this line. For this one, it was greater than, so I was shading everything above the line. So the area where it's true for both is going to be this area all in here, all this area between the lines. Okay, then the thing to watch though is, so my solution is any point inside this shaded area and any point on this solid line. But if they give me a point on this dotted line, I can't include that with my solution because I can't equal to that, not equal to that. Can't use those. Can use anything on this line, can use anything in this area as part of my solution. Okay, other readiness standard. This is where our matrices and other methods are going to come in. So graphing, we just looked at. Use algebraic methods, graphs, tables, or matrices. You can solve by graphing. On your table, it's going to be where your y-intercepts are the same. So let's look at matrices and other algebraic methods here. Solve this system equations by an appropriate method. So I am going to use the elimination method right here. And I'm going to eliminate my y terms. So I'm going to multiply everything here by 2. So that will give me negative 4x plus 2y equals 2 times 18, 36. Okay, and then I'm going to combine these into 1. So 5x minus 4x gives me x. These two will zero out. That's what I'm aiming for, because I want to get what x is. And then a negative 39 and a positive 36, meaning that x is negative 3. Then I'm going to go back up here, and I'm going to substitute in now what I know. So 5 times negative 3, that was my x, minus 2y equals negative 39. So I've got negative 15 minus 2y equals negative 39. Adding 15 to both sides, I get negative 2y plus 15 here that's underneath for 24. Dividing by negative 2. So y should be negative 12. And then I would want to check that, so then I would want to put back in here so negative 12, a negative 15, and a negative 24 would give me a negative 39, and that's a true statement. Right there. Okay, so that's a positive 12. Alright, that looks better. Okay. And then let's solve this system by substitution, because I have this right here can easily become x equals. So we're going to do 2x plus 3y equals 34. And so then I'm going to move this over and use x equals 9y minus 46. And I'm just going to do a substitution for my x here, so I'm going to substitute in my x is 9y minus 46. Equals 34. And I'm going to solve for y. So I get 18y minus 92 plus 3y is 34. And then move this 92 over. And I'm going to combine these terms right here. We've got 21y equals 126. So y is equal to 6. Then I'm going to take that and substitute it back in right here. I've got x equals 9 times 6 minus 46. Oh, and that is minus 6. And it's 46, so 9 times 6 is going to give me 8. Anyways, yeah. Okay, so x is 8, y is 6, and again, you'll go back and check those. The matrices showed up, so I'm going to talk about those too. This was on last year's EOC test. Question is, what is the y value of the solution to this matrix equation below? So in your calculators, the key word you have to remember is reduced row echelon form. And so you're going to use that parentheses. And you're going to set this up 3, 2, 3, 2, 1, 4, like so. Let's see if I can get the calculator to do that. I don't know how to type. 3, 2, 3, 2, 1, 4. So we're going to do REF and parentheses, and then we need to go right here. That's this big one right here in the middle. And you're going to tell it that there are 2 equations, so 2 rows, 3 columns. So 3, 2, 3, 2, 1, 4. Enter. Okay, so the top one is going to be my x value, because I set it That's the way they have it set up, with your x's on top. So 1x is 5, 1y is negative 6. So A is your correct answer here. And then finally, interpret and determine reasonable solutions to systems. So this is basically, you get your answers, what makes sense, gives it a reasonable answer. So example here, if we're solving a system for the number of Class A and Class B tickets sold on a charter flight, what types of answers would not be considered reasonable and why? So numbers we would have to exclude is we could not use negative values because we're selling tickets and we can't sell a negative number of tickets. Let's be positive. Okay, that's not the only restriction though here. We also have to have whole numbers because we can't sell, so this is a discrete situation. We can't have parts of a ticket. So our answers would all have to be positive, whole values. There probably would also be an upper limit. If you think about a charter flight, there is not an infinite number of tickets to be sold. Now in this situation we don't know the size of the charter flight to set that limit, but it would not be infinite, to be sure, because there's a limited number of seats available. We would need a little bit more information to tell exactly where to stop, but you can tell for sure that they are positive whole values. So if you were to set up a problem like that and you got negative values, or you got decimals, then you would have to throw the answer out. Okay, so finally look through the practice pages on Edmodo. I posted several. Bring any questions you have to class or to tutorials. I'll be happy to look at them with you.